Today we're going to take a look at logarithmic properties, and focus on the expanding side of those properties. And then in our next video, we'll focus on just the opposite. We'll focus kind of on the condensing side of these properties. But I officially knew that I was a big-time math nerd when I fell in love with these log properties, and I just love practicing expanding and condensing. So I'll caution you right now. I hope you don't get bit by the same bug necessarily, but these can be really addicting. So what we're going to see by the end of the video, these are kind of the two biggest bears we're going to tackle today is, can I expand something like log base b of the x squared radical y, or log base 6 of, the cubed root of x divided by 36y to the fourth. But again, let's jump right into our very first property. It's called the product rule. And it says, first of all, we have to make sure that the b, the m, and the n are all positive. And of course, the b cannot be equal to 1 either. And if that's the case, we could say that log base b of m times n is the same or equal to log base b of m plus log base b of n. So we're saying the logarithm of a product, the product was right here, m times n, is, okay, remember how is always your equal sign? Sum, you've got your addition sign right there, the sum of those two separate logarithms. So let's practice just using that product rule, shall we? Okay, so let's say we see the product of 7 times 5, right? We could rewrite this as log base 4 of 7 plus log base 4 of 5. And a good way to just say, you're like, wait a minute, there's no way those could be equal, right? Well, what you could do is you could substitute this expression into your calculator, just type it in, and then type in this entire expression, hit enter, and prove that they're equivalent. Now, you may be wondering why in the world, because this expanded version looks uglier, right? It looks uglier, it looks more tedious and cumbersome. There are going to be advantages to both. So there are going to be times where you want to expand. There's going to be times where you want to condense. And really, you won't see the real fruit of your labor until, we get into next week's videos where we start solving equations and things like that and manipulating different expressions. Let's see. On our next example, there actually is product, because when you read this, it's 10 times x, right? So we'll say the log of 10, which is the first term, plus the log of x. Now you can simplify right here. Do you recognize this bear as a common log, right? That has a subscript of 10. And 10 raised to the first power is equal to 10. So this whole expression right there is just a 1. So we may not always get opportunities to simplify those, but if you do see an opportunity like log base 10 of 10, then you do want to simplify it. If I had the log of 100, I would say, oh, that's a 2, and I would just simplify it as much as I could. I didn't have that opportunity up here because 4 to what power equals 7? I don't know. 4 to what power equals 5? I don't know. So it wasn't a nice integer that we could evaluate it to, so I just left it. Okay, after the product rule is the quotient rule. So similar to the last product rule, well, b's got to be positive, m's got to be positive, n's got to be positive, and of course b can't be equal to 1, otherwise everything goes out the window. But basically, so if you see the quotient m divided by n, we could expand that into a subtraction or a difference between these two individual logs. So here, the logarithm of a quotient is the difference of the logarithms. So let's go see if we can apply that rule here real quick. So you recognize that we do have a quotient right here. We have division. So we're going to expand that. We're going to say log base 2 of my numerator minus log base 2 of my denominator. And if there's ever a time where you feel compelled to put parentheses around these guys, you never want to be afraid to do that. It's not mandatory. You don't have to, but it does help sometimes. All right. In our next example, again, you see quotient, you see the division. So we're going to go natural log of e to the fourth minus natural log of 5. And again, we have an opportunity to simplify this expression. We've got a natural or a log with a base of e that cancels out the exponential base of e. So you're just left with 4 minus the ln of 5 for your most simplified answer. So we're always keeping our eyes peeled for opportunities to simplify when we get a chance. The third rule here today is the power rule. And if we said we're going to let m and b both be positive, okay, and then let p be any real number. So p can be negative. It's optional. It could go either way. So again, if you have p up here as the exponent, you could reposition that, kind of reroute it, so to speak, and move it down here as the coefficient. So what does that look like when we see it in live practice? So basically, this coefficient, or this exponent, is going to move and get rewritten as the coefficient down here. So we're going to say 3 times log base 4 of 9. And I don't think I have any opportunities to simplify. This next example, we want to rewrite it so it's the natural log of x raised to the 1/2. So anytime you see that radical x, we're going to rewrite it with a fractional exponent. And then just like on that last example, this exponent is going to move out front. And we'll say 1/2 times the natural log of x. In our last example, let's see. So notice how there are parentheses here. The parentheses are important. That means since everything's being raised to the third, we could move the 3 out here, and we could say 3 times the log of 2x. Now, the directions in this one, they only said use the power rule. If we weren't restricted to just using that one rule, I would go further, and I would say 3 times the log of 2 plus the log of x. But I guess based on the restricted directions we had, we wouldn't do that last step. So let's see if we can put them all together. So we have this toolbox that has our 3 big properties. We've got our product rule, our quotient rule, our power rule, all in this toolbox, and we'll kind of pull them out as needed. The first thing I recognize here in this example is the product right here. So it's x squared times radical y. So I'm going to just use that one rule, and I'm going to say log base b of x squared plus log base b of radical y. So you're just kind of keeping your eyes peeled for product. I don't see any division, so we don't need to use the quotient rule. But what I do see are some exponents, okay? In fact, let's take this radical y and let's rewrite that as y to the 1/2. And then we see these exponents, and we're just going to rewrite them so that they're out on the front. So we'll say 2 times log base b of x plus 1/2 log base b of y, and that's my final expanded answer. Hey, here's a big bear. So what I do see first here right out of the gates is I do see a division sign. So I'm going to use my quotient rule, and I'm going to say log base 6 of, I could say cubed root of x, or I'm just going to say x to the 1/3 minus log base 6 of, and now these parentheses are going to be really, really important right here because you've got the 36 and the y to the 4th embedded there. So now what I see next is a product, right? So it's 36 times y to the 4th. So now I'm going to use that product rule, and I'm going to say log base 6 of x to the 1/3 minus, now I am going to go parentheses, and these parentheses are mandatory in this situation. And I'll do my best to explain why they're so important here. Because you want both these terms, you want the 36 and y to the 4th in the denominator. So that's why the only way to put them both in the denominator is to have those parentheses or those brackets around that expression. Now I'm just going to move all those exponents down. And let's see what we got cooking here. So this exponent's going out here. Let's see. I'm just going to evaluate. You're going to see me evaluate that one in a second. And then this exponent's going to go out here. So we're just going to put all the finishing touches on this and say 1/3 times log base 6 of x. 6 to what power equals 36? And that just becomes a 2. And then we'll say 4 times log base 6 of y. And we could distribute that negative if we wanted to. I wouldn't say this last step is mandatory, but we could say 1/3 log base 6 of x minus 2 plus 4 log base 6 of y if you wanted to distribute that minus sign right there. So that's all there is to it. You've got a toolbox that's got 3 primary tools in it, and you know it's going to be one of those, and you just got to pull out the right tool and apply it at the right time.